Now, we're getting to the beginning of a fairly confusing part of immunology. Immunology is a network of responses, so presenting it in a linear format can be a little bit like, I don't know, watching Game of Thrones. For those of you who watch Game of Thrones, there are so many moving pieces and characters that are all somehow related and converging on one spot, but you don't really know how it ends until the story is finished. Well, immunology is similar. So one way in which we interweave all of these concepts is cytokines. Cytokines are involved in virtually every part of the immune response, and part of the reason they're so confusing is that they work on all of the cells of both the immune response and many tissues within our body, creating a wide variety of responses. So for that reason, I really encourage you, rather than learning each of the individual about 30 cytokines that I might talk about during the course of this course, to actually learn them by their functional groups. Which ones are pro-inflammatory, which ones are suppressive. This way, when you encounter them in a vignette or on a question, or even just when you're trying to figure out what's going on in the immune response, you know kind of what role they're playing in the immune response. And the reason I say this is because the key to succeeding in immunology is knowing your cytokines. They are one of the most important topics in immunology. So if there is one video that I really encourage you to learn like the back of your hand, it's this one. If you're watching this video early in the course, it's probably not going to make very much sense. So listen to it for now as an overview. Later in the course, when you're studying for your final exam, watch it again, listen to it again, and see if everything makes sense now, how I've broken down the cytokines, what the groups mean, and if you can pinpoint where in your immune map each cytokine takes place. So I've broken all of the cytokines up into different functional groups. On this slide, I'm showing the pro-inflammatory cytokines. These would be the cytokines that both initiate the immune response, like our innate and acute phase responses, and also the ones that you might consider kind of like effector molecules, the ones that are really involved in promoting the immune response and eradicating pathogens that we might encounter. So the pro-inflammatory group is broken into your acute phase reactants and the cytokines that are associated either with the adaptive response or as the innate immune response moves to the adaptive immune response. So for the acute phase reactants, we're talking about our type 1 interferons. Remember, this is interferon alpha and beta, and they are produced by virtually all virally infected cells as long as they're nucleated. These cells promote the antiviral state. Remember, they literally interfere with viral replication. Of course, this also includes our inflammatory triad, IL-1 beta, TNF alpha, IL-6. We know these can be produced by macrophages, as I talked about during acute inflammation, but they can also be produced by dendritic cells, fibroblasts, and the epithelium and endothelial cells. They work on T cells, B cells, polymorphonuclear cells. Remember, your PMNs are your neutrophils, eosinophils, basophils. I also have the central nervous system and the liver here. Remember that TNF alpha and IL-6 and IL-1 beta can travel up to the hypothalamus, where they actually induce fever, and that they can actually go to the liver where they can induce basically metabolism of fat and muscle. And when that happens too much, like as we see in cancer patients, you actually get wasting or cachexia, which can be rather painful. IL-6 in particular, when it goes to the liver and works on the hepatocytes, you wind up with an increase in acute phase reactants. Remember your C-reactive protein, your mannose-binding lectin, which both act as opsonins and primers for the complement-mediated cascade. They also can influence T and B cell growth, and as we've mentioned numerous times ad nauseum, promote fever. The important thing to note is that all of these contribute to a significant increase in inflammation. This kicks things off. Then when we move into the next group of cytokines, your inflammatory cytokines, these are kind of prototypical inflammatory cytokines that lead to the adaptive immune response. So in here we have Interferon gamma. Interferon gamma is largely produced by the subset of CD4 T helper cells known as the Th1 cells. These are your quintessential pro-inflammatory CD4 positive T cells. It can also, remember, be produced in the innate immune response by NK cells. So remember, this is where we get some of that paracrine cytokine signaling, where the NK cell or the Th1 cell will produce interferon gamma, which activates the macrophage. The macrophage, in turn, will produce IL-12 down here. IL-12, remember, really helps NK cells and Th1 cells do their jobs. So specifically, IL-12 can help differentiate CD4 positive T cells to become Th1 cells and promote NK cell mediated killing. Its kind of corollary is IL-23, which kind of does the same thing except for Th17 cells, and that can be produced by DCs and macrophages. We haven't really talked much about Th17 cells. Like Th1 cells, they're a pro-inflammatory subset of CD4 helper cells. In this case, they produce the cytokine IL-17. What's important about IL-17 is really its recruitment of neutrophils. For a long time, we didn't know who was creating IL-17, but we knew it was absolutely necessary to continue the recruitment of neutrophils. So even though you have your innate response and it goes on to activate your adaptive immune response, you still want to promote the innate immune response as long as the pathogen is present. And a great way to do that is to have the adaptive immune response produce cytokines like IL-17 that will recruit members of your innate immune response, like neutrophils. We didn't talk much about TNF-beta, but it's also known as lymphotoxin, and really it just promotes the killing of tumor cells, specifically by polymorphonuclear cells. IL-2 I have listed here because in a way it does increase inflammation, specifically because CD4 T cells most often will produce it, which leads to, remember, lymphocyte proliferation. Anytime you see IL-2, think T cell food, but it's also food for B cells and NK cells where it will promote their proliferation and division. Okay, so then we move on to kind of our less inflammatory cells. So these are things like your Th2 cells, which again is another CD4 T cell subset. Th2 cells can be inflammatory, like when they're fighting worm or helminth infections, or in instances of allergic reactions. But typically they're considered less inflammatory than your Th1, Th17, and acute phase cytokines. Think of it as if the acute phase reactants and the Th1, Th17 cells are like a raging boil on a pot of water. Th2 is a little more like a simmer that can burn long, okay? The Th2 cytokines are IL-4, IL-5, and IL-10, but namely IL-4 and IL-5. IL-4 and IL-5 are kind of the inflammatory molecules of the Th2 response, whereas IL-10 is a little bit of a switch hitter. It can be inflammatory, promoting B cell growth, but it can also be inhibitory because it actually inhibits the Th1 and Th17 responses that could occur. IL-4 and IL-5 are absolutely required to get this Th2 response. Specifically, they're involved in T and B cell growth and differentiation into the Th2 phenotype and the class switching of antibodies to IgG, IgA, and IgE. If you're watching this at the beginning of the course, much of what I just said here probably doesn't make a lot of sense, but when you watch it again later when you're studying for your final, hopefully it's all sliding into place as we complete the immune response story. Th2 cells are very much involved in the allergic response, and many of the medications that we look at target either inflammatory responses made by Th2 cells or mast cells, as you'll hear about in kind of the clinical sessions of our courses. All right, the next group are your T regulatory cells. These are your true immunosuppressive cells. These guys literally are the stop sign of the immune system. They make all other immune responses stop. And one of the ways they do this is by producing cytokines that are inhibitory. So you'll notice I have IL-10, listed here again, just like in the Th2. So IL-10 is largely produced by Treg cells, but as I mentioned before, it can be produced by Th2s. And it can promote B cell growth, but literally it inhibits Th1 and Th17 responses. TGF-beta, on the other side, this is the true immunosuppressive cytokines. It literally suppresses and stops pretty much all other immune responses, and it works on B cells, T cells, macrophages, dendritic cells, almost anything you can imagine. And the reason this is important is that as long as an immune response is going on, we haven't truly healed. So anytime you feel symptoms of illness, fever, aches, pains, sore throat, a lot of those actually have to do with the effects of your immune system, cytokines, and things of that nature. So until you stop them, you won't start feeling better. You won't get wound healing. You won't get resolution of fever. So we really need these T regulatory cells to put a stop to the inflammatory response that's been going on. Okay, so the last groups are, some of them are cytokines, some aren't, but I'm including them as soluble factors. So the first is your growth and differentiation group. The growth and differentiation group is really just your growth factors. These are cytokines that work in hematopoiesis of precursor cells, promoting the development of your leukocyte pool. So we have your colony stimulating factors. These are your GM-CSF, your MCSF, IL-3, and IL-7. All of these are going to work mainly in your bone marrow on stromal cells or keratinocytes. Occasionally they're going to come from CD4 cells, and they're going to work on these precursor cells, your common myeloid progenitor, your common lymphoid progenitor, and they're going to promote the hematopoiesis and the directed growth and differentiation of these various subtypes, be it monocytes, granulocytes, the pre-B cells, T cells, and NK cells. Remember that IL-7 is absolutely required for the growth of B cells and T cells. You'll notice here that I have IL-2 again, really just because it creates proliferation and that makes it a growth factor. This last group are your chemotactic agents. Most of these are not cytokines, but they all cause recruitment of cells. So we've talked a lot about IL-8 or CXCL8, which is produced by fibroblasts, neutrophils, macrophages, a lot of cells. We talked a little bit about C5a in the complement videos, really looking at the complement cascade, and I already talked about IL-17. And really all three of these promote the chemotaxis of phagocytes, namely your neutrophils, to the area of inflammation so that we get there and we clean up the mess. There are over 30 others with a lot of confusing names. You really don't need to worry about them. They're created by a lot of cells, and really they all work in concert to recruit all of the cells of the immune response to the site of inflammation. So that's it. So to do well in immunology, you really need to know your cytokines, and to understand them, it's easier to break them down into groups of 5 by function. So like I said, learn this video, watch it early, watch it again late, and then if you have any questions, contact us.